Welcome, everyone, to the second installment, if you will, of our Mekong Water Data Hour. I'm Brian Eiler, the director of the Simpson Center's Southeast Asia program, and it's a pleasure to have you all here to this discussion about sand mining. This discussion in the Mekong Water Data Hour is supported by the Mekong U.S. Partnership. And what we're here to do is to take a deep dive, no pun intended, or a pun intended, into the data that is teaching us about how the Mekong River works as the world's most productive fishery and a river that provides a mighty bounty of agriculture and fishery and other benefits to tens of millions of people in the Mekong. What we do is we take a deep look at emerging data, what it tells us, and importantly, how that data came together through research and how science can speak to evidence and hopefully action. And I can think of no other issue area that needs more urgent action than the issue of sand mining, which we will learn today is happening at a underreported and mostly unregulated rate in a way that is robbing or taking a very important component of the river's mightiness out for other uses. Sand mining hurts the river system and is likely happening at a rate that the sand and sediment that would be coming down the river cannot replace that which is coming out. And just to highlight the importance of sand mining, I want you to think about the Mekong Delta. And that's a patch of land in Vietnam where the river runs into the South China Sea or the East Sea across several distributaries or several rivers as it flows into the ocean. That patch of land is roughly the size of Denmark, or if you're in the United States, the size of West Virginia. And it's entirely created by sediment deposits, by floods that bring sediment and sand down all the way from China through Laos, Thailand, Cambodia, and Vietnam to Vietnam's delta and push land out into the ocean. That is young land in terms of geological processes. The Mekong Delta's land itself is only about 3,000 years old. So in a relatively short period of time, the Mekong Delta was built by sand and sediment processes. That's a pretty impressive process. But now something is happening to chip away at that land building process. And it has to do with how dams are removing sediment or blocking sediment from flowing downstream. And it also has to do with how sand and sediment is being extracted or mined from the river all throughout the river's course and mostly on the mainstream. So today, we're going to hear from some experts who I met actually on social media, on Twitter. And I just wanted to say that Twitter is such a great place, for all its faults, for learning about science and emerging processes that teach us about the Mekong. So we've invited Magdalena Smigai, who's a postdoctoral researcher at the Laboratory of Geoinformation Science and Remote Sensing at Wageningen University in the Netherlands, and Dr. Christopher Hackney, who is at the School of Geography, Politics, and Sociology at Newcastle University. And the two have worked together along with a team of others, but these two have really spearheaded the research to expose how much sand is actually coming out of the Mekong. And we're going to take a focus on Phnom Penh in Cambodia and the Mekong Delta as well, and imagine how the place where sediment is building the river, that's really from Phnom Penh downstream all the way to the ocean, is being taken out. And you have this set of extraction and land building happening all at the same place. After they give their presentation, we've invited two other experts to join us for a discussion. And that's Ngang Nguyen, who's the national coordinator at Open Development Vietnam in Hanoi, and Professor Jitrapon Somyan Nontanakul, who's assistant professor for the College of Politics and Governance at Mahasarakham University in Northeast Thailand. Well, let's take a deep dive into the Mekong and let's go to Phnom Penh and the Mekong Delta virtually to have this presentation from Dr. Hackney and Dr. Smigai. Chris and Magdalena, over to you.
Thank you, Brian. Thank you for the introduction. And hello, everyone. As Brian says, myself and my colleague Magda will be talking. It's a slightly, perhaps different presentation in that it will be in two parts. So I'm going to talk, first of all, about some work I've been doing in Cambodia, and then Magdalena is going to talk more about the Vietnamese Delta and the work that we've been doing down there. So I will test out the screen sharing again. Does that come up? Is that sharing?
Looks great, Chris.
Yeah. Okay. Great. So yes, what I want to talk today is really how we're developing these tools to monitor waterborne activity on large river systems where the Mekong is the example that we've been using, and how we can use these new tools to really gain insight into human activity on waterways, and in this particular case, with a bit of a focus on sand mining or sediment extraction, because it's not just the sand that gets removed, it's aggregates in general. And really, this speaks to a bigger issue in the Mekong. As Brian alluded to in his introduction, these big river systems and their deltas require sediment and water to grow and to develop and to provide the productive landscapes that means that cultures and civilizations and societies kind of end up living there and building their homes on these plains. And this image here is of Phnom Penh, looking upstream on the Mekong itself, with the Basak disappearing off to the middle of the channel. And that's the first distributary of the Mekong Delta. So this is right at the apex of the Mekong Delta. You can see the Phnom Penh skyline that's exploded skywards over the last 7-8 years or so as development in Phnom Penh and Cambodia and the wider Mekong has boomed. And in particular, in the forefront here, you can see this construction and this infill of a large area of reclaimed land, with the blue boats that are the sand barges, filling in that area for future development. And this speaks to global issues around the demand for aggregates. So sand and gravel are the most extracted material on the planet, aside from water. We use about 50 billion tons every year. That's the equivalent to 18 kilograms of sand per person on the planet every day, just to meet society's needs for aggregates. And that's highlighted here in the Mekong, where development population growth is creating this demand as societies economically develop. The easiest place for them to get that material is from the riverbed and from the river itself. And so what we're seeing is this kind of removal of sediment from the channel, and the draining of these sand grains from the river itself. And this is compounded in the Mekong. The Mekong has a lot of different issues going on, not just sand mining, but hydropower development is stopping sediment reaching the delta. Traps these hydropower dams in the upstream catchments, trap sediment behind the concrete walls of the dam and don't let it move downstream. And over years of development, this has been well documented in scientific research, that the sediment loads that are being delivered to the delta in Lower Cambodia and in Vietnam have been in decline for about 60 years or so. As this graph shows here, you can see all these points just falling down towards zero in terms of sediment supply to the delta. This is purely on the basis of hydropower development. So what we're seeing is the greater the development, the build out of these hydropower dams, the more sediment is being trapped. So we have that kind of underlying theme in terms of this, but then on top of that, we have climate change. So we also know that in the Mekong, changing climates are shifting rainfall patterns away from parts of the Mekong that generate sediment. And this is without even thinking about sand extraction. So we've got lots of issues at play in terms of sediment in the Mekong. And just to highlight the scale to you of this, I mean, all those estimates don't strictly take into account good estimates of the extraction of sand. And we can see from this UAV image, just from this shot in the northern Vietnamese Delta up near Tan Chau, just how much of an industry this is within the Mekong Delta itself. So this is a pervasive activity across much of the lower Mekong that is widespread and is removing a lot of that material that does end up in the Delta. And yet it's fairly unconstrained and unquantified. So there have been some prior estimates of sand extraction within the Mekong as a whole. The most kind of reported of these was by Brevard et al. Back in 2013, so that's now 10 years old. There's a series of surveys done on mining operations up and down the lower Mekong basin through Laos, Cambodia, and down into Vietnam. And their estimates are saying that if the whole basin, around 56 million tons of sediment are extracted within 2011. The majority of that comes from Cambodia, and then Vietnam and Laos supplement that with their own extraction rates. But these are 10 years old. Development in Vietnam and Cambodia has grown. Demand for aggregates has grown. It's likely that these are actually underestimates. So that's kind of the problem that Magdalena and I have kind of come to with how do we perhaps update these estimates? What tools do we have now that we didn't have 10 years ago that we could use to improve and perhaps expand these estimates of sand extraction? And one of those is this advance in satellite imagery. So what we've found is that actually in the high resolution satellite imagery that's now available to us as researchers and as the public, we can visibly see a lot of these sand mining vessels. So you can see in B in the center there, these blue vessels that were in those images earlier on, quite clearly within these satellite images. And this is some work that published a couple of years back now that really started this snowballing of how do we monitor this process using these images. So we can see them in the images, we can count where they are, and we can also calculate some of the dimensions of these boats through satellite images, but also just through aerial images, UAV images, things that we can easily collect. And we can estimate the graphs at the bottom there, give some sort of idea of the dimensions of these barges that are being used to fill up. So they're often, nearly 60 meters in length, 8 meters wide. So we can use these dimensions to try and get a good estimate of how much sand they can hold. And if we count them based on a kind of monthly composite image, so when you stack images over a month together, you get a rough idea of where all these sand barges are in that month, and we can count them. And if we do that in Cambodia, so this is the stretch around Phnom Penh, what we see if we look at the red line here, which is the number of vessels around Phnom Penh and Lower Cambodia that are active, so that's we define as 100 meters from the riverbank. So we're not including boats that are moored up and stationary, but ones that are in the middle of the channel. The number of boats over the period 2016 to 2021 has increased from around 50 boats per month up to getting onto 150 boats per month over that 5-year period. Now, from the satellite imagery, as I said, we can calculate the dimensions of these boats, so then we can start to estimate volumes. And if we do that by using these numbers, what we start to see is that the extracted values of sand for this reach of the Mekong have also shown a rapid rise over that 5-year period. I've got some dashed lines on there. So the dashed line in the middle at 32 million tons is the estimate from 2013. From the Brevard study. So our kind of 2016 estimates are below that. There was a ban in 2015 on exports from Cambodia, which may explain why they're lower. But as you can see, since then they've risen back up. This top line up here was the entire Mekong Basin estimate for 2013. And as you can see, based on our estimates of counting these boats month on month in 2020, the volumes exceeded from Cambodia have now exceeded that estimate for the entire Mekong Basin in 2013. The orange bars along the bottom indicate the natural supply of sand that the Mekong can transport. So we measured bedload sediment transport, the amount of sand moving down this reach using some high resolution bathymetric surveys. And we've calculated for each year how much sand the river was transporting naturally. And you can see that the extracted volumes exceed that natural supply every year. So our estimates suggest that now, well, in 2020, about 59 million tonnes a year were being extracted. But since then, some updated estimates place the total now around 90 million tonnes. And that's in part because of that reclamation project in Phnom Penh that was seen in that first image, that the developer's manual itself suggested they need 32 million tonnes of sand to fill that area. So there's that demand coming on top of the normal demand for aggregates in this region. But just to kind of sum that bit up, these satellite estimates that were done by hand, so I manually went around and manually clicked on those boats in the images, suggest that in Cambodia around 10 times the natural supply of sand is being used. But the question is then, how do we scale this up to something that's perhaps a bit more meaningful for wider basin scale? And that's where I'm going to hand over to Magda, who's going to tell the second part of this story. So I will stop sharing my screen and let Magda share hers.
Okay, thanks, Chris. Yeah, first of all, thanks for the invitation here. It's great to talk about this and to follow it up. And I'm supposed to start with, if we're talking about small areas like the Cambodia study site that Chris was mentioning, it is fine to still do it manually. But if you really want to do robust monitoring at a larger scale and over long periods of time, you really need an automatic approach. And this is where we kind of just came in and started thinking together about what would be the best way of doing it. So among the main considerations were to have an automatic approach and also have sufficiently high temporal resolution. So have frequent enough images to actually be able to capture how the traffic intensity is changing. We also had some limitations that we had to consider. So the spatial resolution or the level of detail that our satellite imagery has, because the boats that we're talking about are 20 meters plus in length. So we really need to have very high spatial resolution imagery, which are now available. But a common issue is that the imagery, which has a lot of detail, it's also very expensive. So that also had to be kind of weighed in. It's like, okay, we need the data frequently, we need it to be detailed enough, but we also need an approach to actually be affordable so that it can be sustainable in the long term. So this is where we kind of settled down on planet imagery, with which we still get 4 meter spatial resolution, which is good enough to actually detect the vessels. And in addition to that, we had 1 day revisit time. So the satellite imagery that we're getting, well, we should get it almost every day, if the conditions are perfect. But obviously we've got clouds, and with the 1 day revisit time, we're maximizing our chances of actually getting viable imagery that we can then analyze and derive the traffic intensity. Now, because we're talking about how this type of monitoring can help with identifying the areas where we see the mining and with helping to quantify how much sand is extracted, what we did first was perform some drone surveys. So in this case, our focus area was the Vietnamese Mekong Delta. And we went to different locations along the river system, which were different in terms of the usage, to see what's actually the composition. So we're looking at counting the vessels from our drone imagery. We excluded all the small vessels that we wouldn't be detecting with our satellite imagery anyway. And we were actually quite happy to see that the vast majority of the traffic that we're seeing in all those different sections is related to the sand mining. So on the right-hand side, where you've got these bar plots, whatever's yellow and red is related to sand mining. And on each of those days, we did a few different surveys also to see how that composition is changing over time throughout the day. Because obviously when we've got a satellite overpass, we just get one snapshot from that day. So we also wanted to know how representative that actually is. Can we actually make some conclusions based on that just one snapshot in time? And you can see that we've got a little bit of variability, but in general, the vessel numbers and the proportions of the different vessels are actually pretty similar. So the next step was actually to design our detection method. So how are we going to automate this approach instead of having to do everything manually? So we opted for deep learning, and more specifically, this faster RCNN model, which is broadly used for object detection tasks. So if you see, for instance, CCTV camera footage where you've got individual people identified, this is like the same type of algorithm that we were applying here. We also had to think about what we actually want to detect, because we were relatively restricted in terms of the spatial level of detail. We opted for detecting individual vessels and something that we called clusters of vessels. So for instance, here you've got a few different boats which are merged together. And when they're merged together, we cannot really separate them, and our algorithm wouldn't be able to separate them. So instead, we were detecting this sort of category or class separately, and then using a weighting factor later on, which was representing approximately how many vessels there are in a cluster. And that was based on a mean value from our previous surveys. So using those two classes, we then ended up collating a pretty big training data set. So we used 12 sets of imagery from 2020, and we labeled every single vessel and every single cluster on each of those imagery, which gave us over 10,000 training samples with which we could train our detection model. Why did we opt for imagery from different months? Well, the conditions are changing, so we've got different sediment properties throughout the year, and we want our algorithm to understand that variability and still be able to detect those vessels even when the conditions in the background are changing. Similarly, imagery coming from the different satellites will have different quality. So we also wanted to be able to detect those vessels on different quality of the imagery. When we trained it, we thought that it was performing pretty well, the average precision of 82%. But with the next step, what we wanted to do is to see, okay, let's see how it performs on a data it has never seen before. So we chose randomly chose 2 additional days from 2020, applied our detection model, and checked how well it performs in comparison to our reference data. So on this top image on the right, you can see the detections from our models. So the yellow rectangles are individual vessels, and then the red rectangles are our clusters of vessels. And in the image below, the reference image, you can see our original labels. And yeah, you can see that it's generally performing quite well. Most of the vessels were actually detected. It is struggling a little bit with boats which are moored on the riverbank, because this is like where it visually merges with the riverbank, so it's becoming a relatively difficult object to detect. And we also have, in some cases, some confusion between the two classes, which is to be expected, because those are boats. It's just that you've got a cluster and you've got a boat. But overall, we got like accuracy of 84–85%, which we were really happy with. And it was kind of like high enough for us to actually move to the next step and derive something that can be directly used from this type of data set. So this is just a quick workflow, but in short, we use those initial detections from our model, and we derived monthly heat maps of activity, seasonal heat maps of activity, and also yearly heat maps of activity that then can be like really compared, and these will accentuate where most of the activity was happening in a given month, in a given season, or in a given year. We applied that model to quite a lot of imagery within each year. So generally, we were able to collate 100 to 150 days, depending on the year and depending on the cloud conditions in each year. And with these heat maps of activity that we called this human waterway footprint, we can look at how the traffic is distributed and at how the intensity in the traffic is changing. So on this map on the left, where we've got the dark colors, this is where the intensity is much lower. Where we've got the light yellow color, this is where we've got a lot of boats, a lot of river and vessels clustered together. And based on that, we derived the number of vessels in different provinces in Vietnam, but also in different channels. And overall, over this 4-year period from 2018 to the end of 2021, we've seen that the traffic intensity increased by 25%. And in particular, we saw a really big increase in Dong Thap and An Giang in the upper reaches, and this is where a lot of the mining activity is actually happening. And continuing on that, we also compared more directly on the map how the numbers of vessels or how this intensity has changed from 2021 to 2018. And here, what you can see in the green, and especially dark green, this is where most of the change happened. And this is where the activity really, really increased. So we're seeing some increases around throughout Basak, and also some really big increases, again, in the upper reaches of the Mekong. And this is just like an example next to the border with Cambodia. So this is an example image from 2020, where we see just how many vessels or how many boats there are in space in this small area. And on the graph below, in the black line, this is the average number of vessels and how that has been changing. So this is based on our monthly products. So each dot represents how many boats there were on average in that particular month. And we can see a pretty clear increase. This is one of the non-mining hotspots. Another one has been near another place that I wanted to highlight is near Sadek, and this is where mining was happening quite a lot. Now it's kind of like less intensive, and we can also like really capture that within our monthly data sets. So we see that the peak of activity was in 2020, and since then it has decreased a little bit. And I suppose like before finishing, I just also wanted to mention that, yeah, we've got this nice collection of the data sets, and it is now also like freely available for people to explore of the monthly, yearly, and seasonal data sets are available on this Delta portal. And there's a few final remarks as to like how we kind of just like experienced this whole process and where we see it seeing further. I think that the deep learning approaches like the one that we used here can be effectively used to monitor riverine traffic intensity of a large spatial extents. And what makes it such a nice approach is that it is easily transferable to other areas. All that we need is to refine, or just fine-tune our model. But in all the new areas, we don't actually need such a big training data set anymore. Now, with this traffic analysis, was able to see the mining hotspots, and by kind of just like monitoring how much the intensity is changing in them, in those hotspots, we can kind of just like start making assumptions as to how much sun is being extracted. But the one caveat of this approach is that we cannot directly tell or cannot directly interpret what is the purpose of each individual vessel. So based on our traffic analysis with drone imagery, we know that the vast majority of the vessels, vast majority of the boats in the Mekong are actively used for the mining or for the transport of the sand, but we cannot necessarily make the same conclusions just based on satellite imagery. So the further steps where I see it potentially going is that we can, for now, we just have the detections. We know where the locations of the different boats are, but we can also start looking at the segmentation. So like really getting the sizes of the vessels in an automatic manner. And this really gives potential to approximating the extraction volumes in the non-mining areas, alike what we did in Cambodia. And that is all from me. Thank you.
Thank you, Magda. Thank you, Chris. What a great overview of how both remote sensing and then combined with kind of more traditional methods can be combined to estimate the rate of sand removal and sediment removal from the river. I think one of the most jarring visuals is the knowledge, well, I guess 2 points, is that you've discovered that the past estimates are far underestimating the amount of extraction that's coming out of the river system, and then the replacement factor, right? You're able to model how much sand and sediment is coming down the river under given natural conditions each year, and then demonstrate that what is it, a magnitude 10 times more is being removed than is being naturally replaced. And that sounds to me like a big problem. To explore this problem a little bit more, why don't we open to our other experts who we've invited to join us today, Dr. May Jichapon in Northeast Thailand and Ngang Nguyen from Open Development Vietnam, to ask some questions. And we're going to have an interactive discussion here, and I hope we can focus on, really why does this matter, in addition to understanding how the research was conducted. So May, Nga, over to you. Let's all unmute ourselves and have a discussion.
Thank you, two of you, for your very beautiful and helpful presentation. in my country, Vietnam, we have been suffer a lot from droughts and salt water intrusion over the last decades, and extremely in 2019 and 2020, we have to face up with the most severe drought ever, and that make the government have to call for a state of emergency and call for international support, and yes, the cause of it is like some upstream factors, including the low reserve in the river and the low flow of the Mekong River caused by the mainstream dam development from China to Cambodia, and downstream factors, including groundwater over-extraction to serving the intensive agricultural practice in the delta, and also the excessive sand mining. And we haven't got any data that clearly define the magnitude of the sand mining volume in our country, and I'm really appreciate for your presenting the method. I have a question related to how you defining the hotspot for mining. Is that you cooperate with the partners in Vietnam, or this is the first question, and the second question a little bit detailed about you said that there's a everyday frequency of data visiting on the image, and is that you estimate the volume or the workload for each vessel daily, so that you multiply it by monthly, like you said? Just for now. Two questions. Thank you.
We'll take those, and then we'll thank you. Na. We'll take those questions, and then we'll have some questions and comments from May. Chris, Magda?
Yes.
Magda,
when it comes to the hotspots of activity, as part of this project, we're working actively with colleagues in Vietnam. So when we're also deciding on where we should do the flights, they were actually driving that decision, and they were suggesting these three parts of the river are actually distinctively different. So let's quantify the traffic composition there. So similarly with the hotspots of activity, we're also basing that on their experience, and with with the differences that we started seeing on different years and across the different months. We're also just talking with them. So what do you think has actually happened? Because in one of the provinces in Dong Quang, we can see that the traffic intensity really increased in 2020. So we started just talking a little bit, just why do you think that is? Because then it really dropped in 2021. And we tracked that back to the lockdowns during COVID, because then the monitoring on the ground was no longer happening, which meant that a lot of unregulated mining started to happen. And that's when we see the real increase. And then the drop is when the monitoring on the ground actually restarted. So yes, we've been working quite closely with the Vietnamese colleagues, because I think it's really important to have that local perspective.
That's great. Yeah.
I think just to add to that, as Magdalena said in her presentation, the analysis from the satellite images allows us to say where the vessels are, but not with 100% certainty what they are doing. There are assumptions that the size of the vessel, the colorations of the vessel are very typical of, say, sand mining vessels, and that's why we have that drone imagery to validate the percentages. So actually, what we can say is that month on month, year on year, there are clusters of vessels that sit in these locations along the river. If they were transporting material, then those clusters might not be persistent. But because high numbers of vessels are found in the same locations year on year, then the likelihood is they're there because that is where sand is being extracted from. And that's, again, we have the validation with our Vietnamese colleagues who visit those sites, take the aerial imagery to kind of back that up.
And one more note as to why we're deriving monthly, seasonal, and yearly data sets rather than daily is because we're working on a pretty big spatial extent. So the weather conditions will be very different from one part of the system to the other. So the upper reaches, in the upper reaches, we might be getting a lot of imagery, but the lower reaches might be all cloudy. So again, we wouldn't be comparing stuff like for like. Whereas by making these monthly aggregates, we're getting as much data as we possibly can for all parts of the river. And we have kind of just like also like more approximate, better approximate as to where the vessels are most frequently over time. So in a similar way, if we just have a transit, then that kind of gets averaged out and we're really left with the pure hotspots of where the vessels are sitting.
Sorry for one more question. Are there any physical data that has been collected by the authorities to measure the volume of the sand has been mined that we can use for comparison? No?
Yes, so there are lots of reports. In the Vietnamese Mekong Delta, for example, there have been quite a few studies that have looked at riverbed level changes over a 10-year period. So using repeat surveys to look at how much the riverbed is lowering. Those broader surveys obviously also take into account the impact of hydropower and climate change. But in the Mekong Delta, the average rate of bed lowering is around 0.5 meter to 75 centimeters a year, and has been shown by other research to be the dominant driver of salinity intrusion. So the removal of the lack of sediment, the lowering of the riverbeds is driving that salinity intrusion. Provinces within Vietnam, for example, do report volumes of licensed extraction rates, and they are reported, but the kind of being able to get those values is tricky, and aside from working with local partners that be able to, it's not publicly available information, for example. And the similar situation in Cambodia, where there are published estimations of licensed extraction from the ministries, but again, it's not publicly available to that degree.
Truly, yeah, I agree. Yeah.
Yeah, and I think that, if this were publicly available, then would something be done about it? That's an important question to ask. And the more that that we can, bring these findings to light and get them heard by the right people, which is a question I'll ask later in the hour. We would hope that there is some type of action for regulation or alternatives suggested to meet the demand for this aggregate. Because again, it's going into building buildings by and large, and also filling in wetlands, and filling in land along the river for more development. Chris, I'm glad you touched on Dr. Bin's research there at Vietnam German University. And we're going to have Dr. Bin join us here at probably not the next Mekong Data Water Hour, but the one after that in May, to talk about how the riverbed is lowering as a result of sand extraction and sediment extraction upstream by dams and by sand mining. And how this is, again, as you said, is the main driver of salinity intrusion. So dams, just to reiterate this point that we've been making somewhat frequently, when they release more water during the dry season for hydropower production, they're not helping salinity intrusion. They're not pushing more water out because they're the main driver of why salinity intrusion is happening, in addition to climate change and rising sea levels, of course. I just wanted to bring that point back to the top of the conversation. But May, over to you, May in Thailand.
Yes, thank you for this kind of impressive, presentation. And I would say that I am social scientist, so I know nothing about the technical one. But the thing is, because I'm working quite close to the local activists and local activism. So I was, when you're presenting this kind of thing, I was, what in my mind is, how could the local people apply this kind of data, into their, their local activities? Because in Thailand, there are many kind of people, local people. They are trying to forming a group and try to go against, this kind of sand mining. So, but this one is quite, quite very technical one. So I would like to, can you please elaborate more how can we transfer this kind of knowledge into the local people? And another one is what I'm keep thinking, the thing is in Thailand we have a break for sand extraction. I mean, from July to October, it is like an agreement between Thai authorities and Lao authorities that, okay, we have to have a break because this is a rainy season. The thing is, and there is also, there are also, sand mining, illegal one happened everywhere. So is it possible for the vessel detection to detect this kind of illegal activities? And, this might be very fruitful for the local authority, local administration, because actually in Thailand, this according to the decentralization laws, this kind of, this illegal activity, the local administration can report this one and can, arrest this illegal activity. So this is 2 questions. Thank you.
Okay. Maybe I'll start with the second one. So I think in terms of actually detecting the illegal activity, as long as you know where it's happening illegally, then you can kind of just work on identifying just there's a lot of activity in this area, but actually there's no license. There's no license there granted, so it's probably illegal. But again, it's made kind of on an assumption that we've got a hotspot of activity, we've got a lot of vessels there, so you're kind of making some assumptions around that. One issue with the monsoon season is that what we also saw during this analysis is that on a lot of days we don't get viable imagery to analyze. So that is one of the big limitations around that. So we do get the imagery from time to time. We are able to extract that in some days, but in a lot of cases, for some of the months, even in our current products, there are some areas which are simply missing because for the whole month, there wasn't a single day where we had no cloud cover. So there's one potential limitation. As to bringing these type of data sets to other people, I think, if we kind of just work on a data portal where you can easily visualize the data, or even just on an app, so that the data can be visualized on an app, kind of connected with your GPS location, then maybe that would be a way forward. Because the way we're generating the data sets, they're now kind of just hosted on this website where you can download it. But it doesn't offer the visualization aspects yet. But I see it as that can be an easy next step, just the linking the data set to some kind of visualization that is easily accessed by others.
Yeah, and I would add to that on that first point about how do we transition this from just kind of data into potential useful information for whoever might need that, be that social sort of action groups or regulatory bodies, for example. As much as we've attempted to make this as open access and freely available as possible, I think the benefit of these kind of high return period images, although as Magda said, there are periods where not much data can be captured, but where we do have the data, I've seen plenty of newspaper reports in the kind of English language press from Southeast Asia, and also in Vietnamese newspapers as well, about the community action that seems to be building around sand mining and the threats that are perceived by those local communities in terms of loss of land, loss of infrastructure. These data sets that we've generated allow, to some degree, some sort of evidencing of that, in that it can be used to kind of say, well, look, the satellite image, right? Here's a picture. We can see that this is where the vessels are. This is where they have been. And they weren't here 3 months ago. Or perhaps it's even the other, that actually it's been there for years and maybe it's not that as an issue. So it allows some ground truthing, I think, to the arguments that are potentially made. But the key to all of that is keeping this as up to date as possible. So as new imagery comes in, being able to process that imagery and generate these maps and those locations, and then being able to get them out into the public domain, be that in an app or a web portal or something to just keep it going, rather than kind of get to 2021 and then that's it, stop, because project's finished.
Can I have a quick question? I was wondering if you can use this kind of data to predict the traffic, within the area. Sorry, can you hear? Yes. Can you use the data that you are using right now? Can it be used as a prediction, like a future scenario for the traffic, in the Mekong River? Is it possible?
I think that's a really interesting question. And it will be a useful data set to have in terms of getting to that point. But there are a lot of, I guess, potential trajectories and decisions that will be made at different levels, from the province up to national level, particularly in Vietnam, around what will define those pathways. So if it's used in combination with a set of stakeholder engagements to develop sets of scenarios in terms of what feasible scenarios would look like over the next 50 years, then I think certainly there's potential there for that. It's not something we've explored with that, but I think from any projection, knowing what the base level is always improves the predictability of those predictions. So this can certainly act as that starting point.
But Chris, I've got a follow-up to that. Dealing with prediction, before we get to prediction, let's talk about real-time and near real-time. If you could build a system that would do it as good as it can do, how real-time could this estimation and reporting be? Could we get last week's extraction, last month's extraction, and could we get it, at the end of the month for the month in question? And then what would you do with that? What could be done with those findings if they come in near real time?
Magda, do you want to?
Yeah, in terms of obviously, in terms of the monthly data sets, then we'd be talking about a delay of maybe a few days. So it could be actually brought out in near real time. But like even like within the month, we can get just the individual detections based on the individual days. So that can also be an information source. So, we're not making like this analysis open source because we think that it's can be quite tricky to kind of interpret what's happening. It's much easier to understand the intensity at the end of the month. But for any near real-time monitoring, especially if we're talking about the illegal extraction, then it could potentially also start looking at detections from individual days and see whether that falls outside of the areas that we're expecting to see. Yeah, what was the second part of your question? Sorry.
Well, what can be done with the information if it's coming in real time, or about a month later? What could authorities, decision makers, communities, and researchers do with that information?
Yeah, I think if it's in near real time, then it really opens up options to do some kind of interventions, especially if we think that the activity is happening illegally. So if it's connected to the communities or to the local activists, then they're nearby, and they can actually just like also check if that is happening and inform the authorities. But for that to actually work, yes, we need near real time and we need easy access to the data in a format that is easily understandable.
Yeah.
Thank you. Nga, do you have a question or a comment?
I think that great for chat. I think the delay for just few days is minor, and it is really useful for intervention, or even using as a prediction whether if the government doesn't do any action, then we will have a prediction for them. Yeah, so yeah, very useful. And I think that some organization like us, we are the data user. We often using data source like you publish, and then making visualization or some writing that it is friendlier for popular audience to read. And to use it as their sources for further research or decision making, or any types of use will be helpful. And actually, we will work and started to use your data set. Thank you very much for that. Yeah.
Hey, there's a good outcome of this virtual event. I'm glad that you said that, Nga. And we have our email group chat going. I hope that can continue. We've got some questions in the Q&A list. We'll stick around for a few more minutes after the top of the hour to get through them. One is, since we're on the record, there's a question from Radio Free Asia about well, it says, so the estimate was 56 million tons of sediment extracted in 2011 across the Mekong Basin. What's your estimate for total extraction in 2021 for the Mekong Basin?
Yeah, and that's the $1 million question, right? That's so from the estimates that we have in Cambodia, 2020, we're talking about 59 million tons, is what I was reporting earlier. From the satellite images we've done, we haven't yet got to a volumetric estimate, but there have been some other recent papers in the last year that have provided an estimate of volume for Vietnam. And they were estimating around 49 to 50 million tons. So combining those two, just for Cambodia, Vietnam, we would come out with an estimate of about 100 million tons. That's excluding Laos and further upstream as well. So it's probably at a guesstimate would probably double what that 2013 estimate was.
Thanks, Chris. And thank you for pointing out that this also happens along the Thai-Lao border and then on the mainstream in Laos as well. A question from Murray Hebert. What are the impacts along the river of this massive sand mining beyond salinity intrusion? I mentioned a little bit about filling in of wetlands, and wetlands provide an important service to the people of the Mekong, to the ecology of the Mekong. What else? What are the other impacts?
Well, we know. Oh, sorry, Magda, you can.
No, go on.
So we know that, for example, the lowering of the riverbeds due to the removal of sand clearly drives salinity intrusion, and also propagation of waves and tides upstream. So areas that previously weren't tidal are becoming more tidal. We also know that, I've demonstrated, some of the research that I've been involved in a few years back now has shown that sand mining increases the instability of riverbanks in Cambodia. The work we did in Cambodia, but this is applicable to wherever it happens. So you removing material from the riverbed, you're steepening the riverbank, which makes them more unstable, and then means that bank erosion is more likely to happen as a result of that. So, probably anyone that's looked into this has seen images of houses, villages, infrastructure collapsing into rivers. So it has a whole range of that, and on top of that, you're destroying benthic habitats. You're removing the kind of feeding grounds for a lot of the aquatic invertebrates and biodiversity within the river system. You're digging up breeding grounds where the fish will kind of lay their eggs and nurture their young. There's the potential that it also increases localized suspended sediment, makes water cloudier, reduces light filtration, and changes sort of water chemistry, water quality at the local scale. But then, because this is so pervasive, it potentially has impacts across much bigger impacts. So yeah, the impacts are quite wide ranging once you kind of unpick all the different aspects of the industry.
Thanks, Chris. And I'm glad you mentioned the impact on fisheries, because again, the sediment is not just the basic building block of land building processes in the delta, but it's a basic building block of the food chain for fish and things that thrive on living beings and living organisms that are in the river, because that's the basis for plant production by and large, which fish then feed on. Just two more questions and we'll close down. One is, there was a question from Barbara Best about sediment extraction causing huge sediment blooms that can be seen from satellites potentially. Is there enough difference in the color of the water from extraction sites for satellite imagery to detect? And could satellites be used to identify the actual extraction sites?
Yeah, in some of the areas we clearly see like the difference in sediment conditions, and yeah, these are visibly seen on the imagery. So yeah, that could potentially be looked at. We haven't done it ourselves, but that's potentially a good way of like really narrowing down where the extraction is happening.
And Chris, I know you've done some work on looking underwater, which the satellites can't do. What have you found by looking underwater?
Yeah, so one of the techniques that we've used to kind of, in part, to capture how much sand actually is transported by the river, but the other side is to just see what's actually happening on the riverbed, is use a technique called multi-beam echo sounding. So it uses high resolution sonar system, a bit like having a string of bats, I guess, attached to the bottom of your bed that allow you to map the riverbed in centimeter resolution. I've probably got some images if you
Sure
share and just do a quick show, but we can use those sound pulses that come back off the riverbed to map the riverbed itself. So this is a section of the Mekong in Phnom Penh. So Phnom Penh is just here on this kind of bar here. This is the Tonle Sap River going up to the kind of top left, and the Basak coming off, and the main Mekong coming down. This is a survey we did in 2013. And you can see these sand dunes on the riverbed, which is kind of lovely, beautiful sand dune trains that you would expect from a kind of natural sand bedded river. And then we did a repeat survey back in, well, it was May last year, back in 2022, same stretch of river. And you can see, I'm now drawing stuff on here. But you can see, same stretch, the sand dunes have pretty much gone. And what we're left with in the middle are all these scars and pockmarks, which are where the suction dredging vessels have been removing sand from the riverbed.
Yeah, it looks like a war zone.
So yeah, they are craters. They're often kind of 50, 60 meters in diameter, 5-6 meters deep. And each one is an individual hose that's come down off the river, off the dredging vessel and remove that sand. So you can see it's the activity is happening kind of in pretty much all areas of that channel now.
Thanks. We've got to conclude, which precludes us from talking about a very important question of what's being done about this. And that's come up several times in our Q&A. Obviously, there's now much more evidence to understand this understudied and underreported issue. You know, it's kind of the sleeper issue of the Mekong. There's a lot of attention that's put on how fisheries are depleting, how the Mekong flood pulse is changing and being reduced as a result of climate change and dams. But more and more work is being done in the sand mining and sediment extraction area to bring these impacts to light. We can talk about what's being done. I'll just conclude that in less than a month from now, there's the Mekong Summit in Vientiane, hosted and sponsored by the Mekong River Commission. You know, what you've outlined is this is a transboundary river issue that needs to be addressed in a transboundary way. Let's hope, and I'll do my best to get this information to those that are working on this issue so that it can be discussed at high level fora like the Mekong River Commission Summit. So with that, we are going to close down. I just want to thank our speakers, Magdalena Smigai and Chris Hackney, calling in from Europe, as well as Mei Jitrapon and Ngang Nguyen, calling in from the Mekong region. This is the second of our Mekong Water Data Hours. We'll have another one in April, and we look forward to seeing you and your questions and having a fruitful discussion then.